Welcome to part 2 of chemical bonding. This section is about covalent bonds. Now, as a refresher, remember we talked about ionic bonds. Ionic bonds is when electrons are transferred from one atom to the next. And the goal of each atom is to look like the closest noble gas or to get an octet, a full 8 electrons. So the goal remains the same for covalent bonds. Elements or atoms are trying to get to a full octet, 8 electrons in their last shell, unless they only have one shell and the maximum you can put in the first shell is 2. But besides that, most atoms are looking to get 8 in their last shell. So in covalent bonds, the reaction, the bond happens by sharing of electrons. So instead of give or take, you're going to have two atoms or more share their electrons. So here's an example, chlorine. So chlorine is a really reactive gas and it comes in pairs. It's what is called, often called a diatomic gas or diatomic molecule. And chlorine is diatomic because it comes in two atoms as Cl2. So let me show you how chlorine bonds with itself and why that is called a covalent bond. So how will the two chlorine atoms react? Each chlorine atom has 7 valence electrons, and each chlorine atom wants to gain one more electron. Now, when neither of the chlorine atoms want to give up an electron, they both want to take and accept an electron because they're only one away from 8. What do? So these chlorine atoms are called very electronegative. Electronegative means they love electrons. They have a high tendency to hold on to their electrons. So if both want to hold on to their electrons, neither one of them wants to give up, you really cannot do an ionic bond with chlorine, two chlorine atoms. So what you end up doing is you end up putting the two chlorine electrons that were single together. Now the atom that's on the right has 8 electrons, one of which belongs to the other atom. And now that's an octet. And the atom on the left also has 8, although one of them belongs to the other atom. And that's an octet. So this octet is achieved by sharing the electrons that are right here in the center. The electron pair in the center is what is being shared. And that is the bond that covalent bonds make. This is called a bonding pair. And in the case of chlorine, there is one bonding pair of electrons. Therefore, single bonding pair. This is called a single bond. And later on in this video, you'll hear about something called double bond and triple bonds. But for the most part, you will need to understand what is a single bond. So single bonds are sometimes written with a dash, but I would really like you to write them more so like this. So here's an animation to show you what happens in a covalent bond. So these are two atoms. They bond with each other and their last shell now overlaps and now they're stuck with each other. As opposed to in an ionic bond when there was a give or take of electrons and charges that were attracted to each other, in covalent bond there's actually a physical overlapping of the electron shell or energy cloud that keeps the two atoms together. So open up your notebook and copy this chlorine atom in your notebook. I want you to copy this chlorine atom because I want you to use this format to answer all the questions that we're going to answer now. Every time you're trying to show a covalent bond, this is how I want you to show it. So in your notebook, see if you can show me how two hydrogen atoms would form a covalent bond. So go ahead and hit pause in this video and give that a try. Remember, hydrogen atom each have only one valence electrons. So neither one of them really wants to give up its electron. It's possible for it to give it up, but it's not that easy. So each hydrogen atom is reluctant to give up its one electron. So you're going to have to do a sharing situation. Show two hydrogen atoms sharing electrons with each other. So go ahead, hit pause and try it. So this is what your answer should look like. Now remember, hydrogen only needs 2 electrons. It does not need 8 because hydrogen only has the first energy level. If you only have the first energy level, you only need 2 electrons. So here's a bigger picture of it, so you kind of can envision what's happening. So when the hydrogen atoms share electrons with each other, their electron clouds actually overlap. Similarly, when the chlorine atom shares the electrons, their electron clouds overlap with each other and they're bonded with each other in this sort of a way. So let's continue trying a couple more examples. See if you can show me how hydrogen and chlorine will bond and how hydrogen and oxygen will bond. Hydrogen and chlorine together make hydrochloric acid, which is very common to find in your stomach and for digestion. And hydrogen and oxygen together will form water, H2O. So go ahead, hit pause and try this. Now I'd like you to just call me over to make sure you got it right, or if you're confused, go ahead and call me over and I can help you with it. So water molecule should have looked like this. It's oxygen with 2 hydrogens next to it. And then fluorine is another example. I know you didn't have to try it, but you can kind of get the idea of something else that's also diatomic. So this is a slightly challenging example. It's okay if you don't get to this part. It's okay if you you ran out of time before this. And it's okay if you kind of sort of understand this part, because this is going to show you what a double bond is. So in the case of oxygen, each oxygen has 6 valence electrons. And the 6 valence electrons, oxygen's very electronegative. It really likes the electrons. It already has 6. It only needs 2 more. So it really does not want to give up any electrons. So oxygen actually never gives up its electrons. It always gains electrons. But when you have 2 oxygens together, what do? You have 4 unpaired electrons. These 2 electrons are going to share with each other, and these 2 will end up pairing with each other. So then you have something that looks like this. So in this kind of a molecule, you have 2 sets of electrons that are bonded. Both electron pairs are shared. So now oxygen has 6 valence electrons, but it's also sharing 2. So now it has a full octet. And the oxygen on the left also has a full octet. You have 2 bonding pairs. And this is called a double bond. You can write it like this, showing the electrons, but you can also show it as 2 dashes. So this is an oxygen molecule. Oxygen is also a diatomic molecule. All right, so we're gonna, I think, stop right here. Yes, we'll stop right here. And at some point in class, I'll show you a triple bond as well. But for now, let's stop here and hope you learned this. And we'll continue studying this as time goes by. All right, bye.